Hi everyone, and welcome to today's Physics Daily Booster. This is number 7 in the series, and it is an advanced information listed topic. What we're going to be looking at today then is the kind of 2.2 section of physics. So we're going to continue looking at forces and their effects and how they interact. What we're going to focus on first of all then is this idea of terminal velocity. So quite simply, one of their favourites here is either a skydiver or someone jumping off a diving board. So watch out for those two as kind of key examples here. Now, if we think about what happens, we've got this little graph down here that's going to show us basically the different stages, which we can pair up with our little diagrams showing the individual forces acting on the object. So if we look at part A first of all, this is when they first jump out of the plane or jump off the diving board. So at that point, what we can see is if we look at the force diagram in box A, then we've got force of weight pulling down towards the earth, but we don't have our force of drag at this point. So that means we're going to accelerate, which we can see in the graph by that diagonal line. As we get to point B, what's happened is drag has increased, as we can see from the blue arrow there, and therefore we're starting to slow down in terms of our acceleration. When we get to part C, that horizontal line, then we've got equal forces of drag and weight, and that is terminal velocity. So at that point, because those two forces are balanced, our skydiver or diver is going to fall at a steady velocity. When we get to point D, they open their parachute, and as a result of that, we've got a much larger surface area, so drag increases. Because of that, drag is greater than the weight, and as a result, the velocity is going to slow down, so we have a deceleration there. And then finally we get to part E, which is again where those two forces are balanced once more, but they're balanced at a lower speed. Now, the reason that they become balanced again is that as we then start to slow down, then we have a much smaller force of drag, which then eventually leads to the two equaling out once more, just at a lower terminal velocity that means you'll land nice and safely. There can be situations where we deal with forces that act at different angles, i.e. not right angles or opposites to each other. So what we'd have to do in that scenario is resolve them, so that we'd only be left to deal with forces acting in two directions at right angles. Now, this I don't think is going to come up on your exam paper for the simple fact that they don't expect you to have a protractor as part of your standard equipment. And without your protractor, you can't actually work it out. So we're not going to spend any time on this because I don't think it's going to come up. Next up is looking at rockets. So we're looking at some everyday examples of where these forces actually come into play. So if we're trying to launch a rocket to get something up into space, then we've got to overcome the force of gravity that holds things obviously here on the ground. Now, what we need is a big resultant force basically, in order to produce the acceleration we need to get out of the gravitational pull of the Earth. So what we do is we have a massive amount of fuel that we will burn. That produces a large amount of gas that then pushes out the bottom of the rocket. The gas pushes on the rocket pushes on the gas, Newton's third law, every action has an equal and opposite reaction, remember? And as a result of that, when the force of the gas is greater than the force of the Earth on the rocket, it will accelerate and lift off. We do have a calculation here as well, momentum. Remember, formulas all given to you on the formula sheet, so you don't have to remember it, you just need to know how to use it. Now, there are two things that momentum depends upon as far as objects are concerned. The first is their mass, the second is their velocity. Now, because we've got velocity, that means momentum is a vector, so it has a direction as well. So what we can see is our little formula at the bottom. Momentum is the mass times velocity. So what do we need to look out for? We need to look out for the mass being given to us in grams in the question. If it's in grams, convert to kilograms first, then substitute into our formula. The last little bit of today's booster is looking at collisions. Now, when things collide, then we need momentum to be conserved because we have a law of conservation of momentum. So that just tells us that the momentum before must equal the momentum after. So we have elastic collisions, and that's where the kinetic energy is conserved when a collision takes place. So the kinetic energy store will remain at the same level. That just tells us that if one ball hits another one, then we will find that the exact same speed of the second ball would be actually seen. So whatever speed the red ball comes in at would be the same speed that the blue ball goes off at. In reality, that doesn't happen because some energy is transferred to the thermal store by sound. The second scenario then is what we refer to as inelastic collisions. Now, these are the collisions where the kinetic energy is not conserved. So that just tells us that some of the energy is being transferred to other stores. So this is pretty much what we see in real life, because not everything is transferred from one kinetic store to another kinetic store. Some is transferred to other stores here. So the example we had on the previous slide of our snooker balls colliding, then some of the energy being transferred as sound to the thermal store is a good example of how we have an inelastic collision. So do remember that this is where the end velocity of those combined objects will be lower than the original objects, because some of that kinetic energy has gone to the thermal store. Last thing to do for today then is head on over and have a go at the quiz. Obviously identify if there are any bits that you haven't really understood. If there are, then I would suggest obviously taking a little bit of time to go back over those through other means, either using the revision guide, the main videos on the channel, or obviously you can use other resources like obviously your exercise books, and have a look at some of the past exam questions as well. And don't forget to join us again tomorrow for our next Physics Daily Booster.